Hello guys, welcome to the explanation part of the live quiz on number properties that you just completed. And congratulations first of all to Manish, Sarthak, XYZ, Arpit and Shivam for being the top 5 students who did really well in this quiz. Now, in this part of the session, we're going to go through not just the explanations of the questions that you did. As always, I try to add more value than just explaining how the questions work the way they work. So we'll look at better methods of solving the questions. We look at a lot of other things that GMAT really tests you on, how they try to play with your psyche, how they try to put you under pressure with the language or whatever. And those skills also we'll try to see. Okay, I know all of you are excited to hear all of it. So without any further ado, let's just get into it. But just a quick introduction about myself. Not all of you might know me. Some of you who watch my videos do. So a quick introduction about myself. I have 11 plus years of experience mentoring students targeting MBA from tier 1 schools globally. You think of any B school in the world, I've helped people get into the schools as a teacher, as a mentor, both. I prepared and taught for CAT and GMAT myself, scored a 740 on GMAT Classic and 99.9 percentile on CAT. And personally, I like analyzing trends and data to come up with my strategies. I help people with the GMAT prep, with their applications, and in the last year alone, a lot of students who have taken private tutoring with me have scored 705, 715, 725 scores like those, and some great improvements have happened in the recent past. So all the learnings that I have with over a decade of experience teaching students to get past the dream score on GMAT, I'm gonna take them today into consideration while solving these questions with you. Okay, so let's jump into the first question. Now, a fairly straightforward question to start with, right? You read this question, you see it's a sequence of 8 consecutive odd integers with increasing values, has 9 as its 7th term. Okay, I'm just gonna remove the GMAT Club logo for a moment because I think it is interfering with the question screen. Yeah, now I think the question should be fully visible, guys, right? Hold on. Great. So, and one more disclaimer, I am a little bit under the weather, not at my best. Overall, have a bit of a cough, so you might have to bear with me. I've taken some medicines and all, so should not be too bad. But yeah, just giving you a disclaimer. Okay, so the sequence has consecutive odd integers, and they are telling us that the 7th term is 9. Now, many of you would be able to solve this by just simply writing down the numbers, right? It's consecutive odd numbers. So if this is 9, the last one is supposed to be 11, and then it is 7, 5, 3, 1, and just count your way through, right? Just write it from that side. So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 terms, and that's done. What is the sum of the sequence? You just add them up. You'll realize that it ends up becoming dependent on these terms only, and you get the answer as 32, right? So fairly straightforward question. If you see it that way, not much to like discuss, much to learn. But if the question is changed, if the question becomes like something like this, let's say for example, it says that 9 is the 71st term, then obviously you'll not be able to write all the 71 terms out, right? Then it will become a difficult question to solve. You can't write them down. You have to use formulas and understanding to solve it rather than just putting down all the numbers on the page or the paper or the like whatever notepad you're using to solve the question, correct? So what do you do in that case? I'm going to teach you a foolproof method. Now obviously, just for a disclaimer, in this question I am not recommending to use that method, simply because in this question it's very simple, right? You can just write down the numbers, no need to strategize, no need to think. But if the number is bigger, which is most likely going to be the case if it's a hard or medium level GMAT question, then how should you tackle it? So please understand, we are talking about arithmetic progression. In an arithmetic progression, the median is equal to the mean. This is something which can be really, really helpful in you solving a lot of questions. And the question is talking about the sum of the terms. Now, there are multiple formulas of the sum, right? One of the formulas of the sum is this one. Now, tell me, guys, how many of you like this formula? How many of you, let me ask this question. I want you to respond in the chat with me. How many of you hate this formula? Sn is equal to sum of n terms is equal to number of terms divided by 2 into 2a plus n minus 1 into d. How many of you hate this formula? I just want a yes, no. If you hate it, yes. If you don't hate it, no. I'm a lazy person, honestly. I don't like this formula at all. Just too much of effort for me. Okay. But if you also hate it, just say yes. If you don't, then you can say no. Yeah, it's okay. Dasa says, I don't hate it. Shreya says, I do, yes. Again, I don't have a personal enmity against the person who has created this formula. Please understand. It's an important formula. You need to know it. You need to learn it. But at a certain stage, you need to surpass that formula if you want to do questions better, faster, more efficiently. Okay. So I like, possibly Shreya, you are at the same stage as what I'm expecting to. But yes, as I said, very importantly, you need to learn this formula initial days to build the basics. But as you move, as you progress, you might have to undo this. For GMAT, technically, you don't need to use this formula for any question. This formula actually comes from another formula, which is this one. And the good thing is, this formula also comes from another formula, which is simple. Sum is equal to n into average. Now, I generally recommend my students who work with me to focus on this formula, use this formula, and to use this one, like this should be the first to find the sum. And this should be the second choice usually. In some cases, the second choice can become a first choice, and we'll talk about that also in the next question. So I'm going to use that concept, okay? I'm going to use this concept. I'm going to rub everything on the screen for a moment. And I know that sum of n terms of a series, arithmetic series, is n into average. And I know in the arithmetic progression, average is same as the median. So again, if in case you get a question which is like having a bigger number of terms here, then I know that I'm talking about 8 terms here. So if I'm talking about 8 terms, the median is the average, and both of them are nothing but the average of T4 and T5, basically. So you can say T4 plus T5 by 2. Okay. So if I can find the T4 and T5, I can find the average of that. I just need to multiply 8 with that number. Very simple. Okay. Now, how do you find that? If someone is interested to know, T7 is 9, correct? Now, if I want to go from T7 to T5, I know it's a consecutive odd numbers. So I'm going 2 terms backwards. 2 terms backward means I'll just have to subtract 2 times the common difference. And the common difference here is nothing but 2 because they're consecutive numbers. So T5 will be 5, T4 will be 3, basically. And the average of that is 4. So my answer is 32. So you don't have to, in an arithmetic progression question, you don't have to go back to a plus n minus 1 into d formula to find out the first term and the common difference and get the value of other terms. You can move between any 2 terms, just see how many terms are you moving backward or forward. So when I move from T7 to T5 over here, I moved 2 terms backwards, and then I can get to that by subtracting 2 times the common difference. Very simple. Okay, and that can help you solve questions a lot more easily. Like this is a straightforward question, I know. Harder question, this will work like magic. I've seen students save 2.5 minutes plus on a hard arithmetic progression sum based question using this concept. Okay, now let's go to the next one. Again, it's a similar topic. Why T4 and T5? Again, it's a median. You have to calculate the median. The median is basically like, just go back a bit. Those of you who don't know how to calculate median is just a second. What's happening? Let me just get the marker. I think the pen is not selected. Yes. So median is n plus 1 by 2. Okay. Understand that, Ray. Median is n plus 1 by 2. The number of terms here is 8. 8 plus 1 by 2 means 4.5. So the 4.5th term is the median. So you have to find the average of 4th and the 5th term. Okay. In fact, when I do sessions with my students, I don't even ask them to find the average of 4th and 5th. I directly ask them to find T4 4.5. But again, I can't go deep into every concept in this class. It's just in this session. So it's just too short to discuss every concept in depth. But I hope you understand the idea, right? You can find the median, which is the average of T4 and T5. If it was odd number of terms, instead of 8 consecutive terms, it was 9 consecutive terms, it would lead you to a single term alone. You don't have to find the average there. Okay, guys, let's move ahead to this question. Now, this is a very classic, let's say, trap question, I would say, as per GMAT. A lot of students see this question and they think that I have to use this formula, sum of first n positive integers is equal to n into n plus 1 by 2. Which is given in the question. And that's a trap. I've seen a lot of GMAT official questions also where they give unnecessary information which they expect you to know as a trap. They want you to use that information. Sometimes you use it and you might get stuck. I'm not saying it's always a bad thing. Sometimes the information is helpful. You need to be able to decipher when it is helpful or not and take a strategic call whether you should use it or not. Honestly, in this question, I don't recommend using it. It simply says the sum we have to find for all the integers, positive integers from this to this. So I should not try and use this formula. There's no need to use this formula. I can use my second choice. My second choice was the sum of n terms is equal to n by 2 times first term plus last term. So I just need to find what the number of terms is. Here I know the first term and the last term. So usually, when should you use the first term and last term formula for finding the sum? When you know the first term and the last term. If first term and last term are known to you, just use this formula. Don't use the first choice formula, which is n into average. Okay, very simple. That's the way you should think. So this is basically 600. I now need to find the number of terms from here to here. How do I find it? I simply subtract the largest from the smallest. Sorry, smallest from the largest. Whatever I get, I just add 1 to that. And that's my number of terms. So that will give me 101. So I just multiply this with 101, and that's where, okay, and I have to divide by 2 also. Just remember that. So I'll divide by 2. I'll get 300. So that will give me 30,300 as my answer. Okay. Just give me 1 second, guys. Okay. So I'm back. Just 1 second. I'll just sip some water. Okay. Sorry, you would have to bear with me a little bit under the weather. So let's go to question number 3. Now, question number 3, another fairly straightforward question, asks you to find the units digit. Now, if you know the concept of units digit, the idea is units digit is dependent on the units digit of the base number and the exponent or the power which the number is raised to. So technically, 3 has no role to play in it, 9 has no role to play in it. Now, 5 to the power anything ends in 5. On the other hand, 3 to the power anything, 3 has a cyclicity of 4. The unit digit of powers of 3 will repeat in this pattern. Now, if you notice 46, if you divide 46 in multiples of 4, you'll see that 46 is of the form 4k plus 2. That means you need to pick the second number from the cyclicity of 3, because the 3 to the power 46 will have the same unit digit as 3 to the power 2 would have, which is 9. So 14 is the sum. So 4 is my units digit. Straightforward question. Those of you who know the concept of unit digit will get this right. If you don't know, you need to go through the concept of cyclicity, learn it, and you'll not have a problem with this at all. Now, sometimes GMAT very tries to trick you by giving you questions where they kind of squeeze in this 5 somewhere, right? And then there are like other things which are multiplied with it. And if you know that anything multiplied with 5 will yield me 5 as a result if it is a odd number, and if it is an even number, it will yield 0 as a result. You don't even need to find the unit digit of the other things, only need to find the odd even nature. Again, those are small concepts which they test and can actually help you get the questions right faster and more efficiently also, by the way. Okay, now let's go to this question, the first DS question that we have for today. Now, slightly tricky question in the beginning if you see. The question is asking us if A and B are basically positive integers, and A by B is expressed as a decimal. Is it a terminating decimal? So the pre-analysis that you need to do, and again, I watched my previous sessions, I've talked about the importance of pre-analysis in DS. A number is a terminating decimal only if the divisor in the simplest form, not in the current form, in the simplest form, when you cancel out all the common elements, the divisor is only a multiple of 2 and 5, basically, where m and n could be any integer greater than or equal to 0. It's all good. Till the time we have only 2 and 5 in the denominator, or one of them in the denominator, or a combination of the two, in the simplified form, I can say it's a terminating decimal. If that's not the case, I can't say it's a terminating decimal. So if I look at statement 1, it's not sufficient. It only tells me what is there in the numerator. Doesn't help alone, right? I need to know the denominator. Second statement tells me b is equal to 3. Doesn't help either, right? I might have, some of you might mark b as the correct answer, thinking that, Piyush, what if b is equal to 3? Then I can say for sure it's a non-terminating decimal. You can't be still sure about whether it is a non-terminating decimal, because understand it's possible that a could be a multiple of 3. If a is a multiple of 3, what will happen is the 3 which is common between the numerator and the denominator will get cancelled. For example, if a was, let's say, 9, okay, and if I divide 9 by 3, I'll get a terminating decimal. Okay, in this case, the answer to the question is yes. But if a isn't a multiple of 3, it isn't a multiple of 3, then my answer will be no, because the denominator will then be not a multiple of 2 and 5 only. So alone, both these statements individually will not work. They will not work individually. But even if I combine them, now understand, even if I combine them, in order for me to be 100% certain that it is a terminating decimal or a non-terminating decimal, I need to know whether the 3 gets cancelled or not. Now, if you look at the numbers for a, it could be anywhere between 51 to 60, right? Now, if I have a is equal to 51, that will lead to a terminating decimal. But if I have a equal to 52, this will be a non-terminating decimal, right? This is a terminating decimal. So I am still getting both the answers, and that's why answer would be E. Okay. But main learning that you have in this question is, whenever you see a question which says, is A by B a terminating decimal? The denominator, remember, not in general, in its simplest form, the denominator should be a multiple of 2 to the power m into 5 to the power n, where m and n could be greater than or equal to 0, any number. So they should only have these two factors. That's it. I hope that's helpful, guys. Let's go to question number 5. Now, another interesting question. This kind of questions I call are trap or tricky questions, whatever you want to call it. If you try to do them too fast, you might end up making errors, which some people call silly mistakes. Some people call, like I call them, like really, really costly mistakes, because just 5-10 seconds extra could get you the right answer. And GMAT being an adaptive test, you get the wrong question, like wrong at the wrong point, like it can really, really impact your score very. You don't want to be doing that. So let's understand these questions carefully. It says A and B are non-zero integers. That means A and B could be positive, could be negative. They are just non-zero and they're integers, very, very clearly. Okay. Now the question is asking us, which of the following must be negative? So I don't care about whether they are even, odd, what is the value. I just care about whether they're positive or negative. Okay. Now I need to be 100% certain about the number being negative. Now, whenever you see something like this, whenever you see something like this, like must be true question, for example, you convert and try to solve it as a could be false question. So instead of trying to see whether it is positive true, you try to see if it is false, then it is definitely not true. Similarly, this question says must be negative. I'll try to look at it as could be positive as a question. Okay, that's one way to approach this, guys. Understand, that's a very important tip that I'm giving you. Never try to solve a must be true question to try to prove it true, unless you can infer something directly. That's a good thing, obviously. But otherwise, you should try to take it as a could be false question and try to prove each of them false. Now, if you notice carefully, since we are worried about the positive negative nature only, the power might not play its role. Like the negative thing in the power is not going to play any role, because it just says that this is equal to this, right? So then whether this one is if this one is positive, even this entity is going to be positive. Basically, both of them are going to be the same. So the minus in front of B is not going to create any problem for me. Okay. Now, if you notice very carefully, this is something which will always be positive, because it's like raised to the power even power. If even if A is a negative number or a positive number, when you raise it to an even power, it automatically becomes positive. Correct? If you know that, then this question will not pose much of a challenge for you, because you know that, like, just give me 1 second, guys. So if you know this property, basically you are 100% sure that like the power, basically where you have an even power, the number is going to be positive, right? So I can ignore this right away. I can say this is not positive. Now, if you notice this, for example, this over here, using the same property that I just talked about, okay, that when the power is even, no matter what you raise it to, like whatever is the base, that is positive or negative, if it's an even power, it will make it positive. Now, if you know that, then you know that the term within the bracket is definitely going to be positive. Correct? This is definitely going to be positive. Now, if this is definitely going to be positive, the moment I put a minus sign in front of it, it is definitely going to be negative. And that's my answer. Okay. And that's what I tell my students, that you should not, like in such questions, you should be observant. You should observe, draw certain inferences. Sometimes these inferences can actually help you solve questions faster. A lot of people would have solved this question using numbers. Like, how many of you use numbers to solve this? That let me take a as -1 and my 1 and just try and solve it from there. Again, I'm not saying it's a bad strategy. In this question, works, definitely. But some other questions, it might take you a little longer. It's very important in algebra questions like these to observe. And if you observe, you draw these inferences, you will be able to do a very good job at solving the questions, and not just getting them there faster, but even more efficiently. You will save a lot more energy when you're doing these questions. Okay, let's now look at this one. Okay. Let's go about this. Again, another series type of question, which tests your understanding. Now, if you know a formula, sum of first n positive, let me say positive odd integers is equal to n square. Okay, if you know this formula, this question will be like a very, very straightforward question for you. Again, if you don't know this formula, it might take a little longer. Again, I'll show you how to solve that without the formula also. But let's understand, if you know this formula, how it works. So the question says, the value of k we have to find if we are adding all the odd numbers from 1 to k. Now, again, please understand, the nth odd number is actually in value equal to 2n minus 1. Okay, so if I say that k is the nth odd number, I can say k is equal to 2n minus 1. Okay, now I know the sum is gonna be n square, right? That's my formula, right? That's what I know. In GMAT, which is teach this formula as a part of our curriculum, because this comes in handy in GMAT questions. Like a lot of questions, we have seen tricky questions where you can use this very comfortably. So if you know that formula, you know 441 is n square. So if you solve this, you'll get n is equal to 21. Another important note, guys, those of you who want to do well on GMAT, certain calculations, certain numbers you need to remember. GMAT expects you to know them. One of that is all the squares from 1 to 25. You need to know the square of all the numbers from 1 to 25. If you know that, then this will be easy. It's very easy for you to understand that 441 is 21 square. It comes in handy. So I'll just recommend you to memorize them. If you don't memorize, know them. So if I know n is equal to 21, I just need to place n in this equation, and I'll get my k. So if you solve for k, you'll get k as 41 over here, and that is your answer. Okay, very simple. If you know this formula, just a very simple process to solve this question. Okay, and in case this is the formula that we definitely teach in our coursework. If you want to understand how we can help you improve your score, feel free to reach out to us. The details are on the bottom of the page. Also, you can see our support email ID, and I've also given the link to block a call on our calendar if you want to understand how we can help you. But yeah, these small things can really add up. Like, you don't have to really go and solve every question in the traditional way. And with the GMAT Focus Edition giving a lot of impetus on Quant, because there's a lot more improvement in Quant possible. Quant is the easiest section where you can get to a Quant 90, to be honest, the perfect score. And in GMAT Focus, your total score is not dependent on your subsectional breakups. Like, if you improve by 2 points in Quant, the total score goes up by the same amount as it goes up by if you improve by 2 points in verbal, or you improve by 2 points in DI. And Quant is the area where it is easiest to improve the score. So knowing these small hacks can actually really help you. Okay. So Thomas says, I'm doing GRE again. Since we are doing GMAT focused questions, I am focusing more on the learnings for GMAT right now. Okay, great. GRE is different level of adaptive, Thomas, and GMAT is a different type of adaptive. We can get into that discussion, but I'm not getting into it right now because we are focusing on something else. So coming back to GMAT again, the idea is that knowing these neat tricks can really help you in doing a lot of these questions in a better, more efficient way. But let's say you don't know this formula, then obviously you'll have to go through the regular route of solving this. So again, you know that you're adding all the odd numbers from this to this. The sum of this is 441. So you'll go to our second choice formula. If you remember, we talked about that in the beginning of the session. So I know the number of terms divided by 2 into 1 plus k is equal to 441. Now I have to find the number of terms. Now what is k? If I have to find the number of terms, I can say first largest term minus smallest term divided by 2 plus 1. That is basically n. So if you solve from here, you'll get n is equal to k minus 1 plus 2 by 2, which is nothing but k plus 1 by 2. So if you notice, this is basically going to give you k plus 1 by 2 times k plus 1. Okay. Okay. And then there is another half in the front because n is to be divided by 2 also. So you will get 1 by 4 times k plus 1 whole square is equal to 441. So I can say k plus 1 whole square is equal to 441 into 4. And then k plus 1 would be, if I do this, 421 into 2, taking square root on both sides, which is 42. So k is equal to 41. So if you don't know the formula, you'll have to go through all these steps to calculate the answer. Basically, that's the second best way of doing this question. All right, guys. To show you both the methods, trying to do my best to kind of help you understand all different ways to look at it. So what is important is that you look at this question and you strategize what is the best way to go about doing it. If you know two methods, you can use the better method in that particular question. Now let's come to this question. Another fairly straightforward question if you just use common sense logic, but we'll also try to understand and learn something additional from this question. If there's a slightly more difficult question, what should be the process to solve it? But if you look at this question, it says n is a product of 2 and 3 and a 2-digit prime number. Let's call it xy, okay, where xy is a 2-digit prime number, x and y are the tens and the units digit of it. Now it says how many of these factors are greater than 6? Now understand it this way. If it's a 2-digit prime number, xy is also a factor, which is a 2-digit number, so definitely greater than 6. 2xy will also be greater than 6. 3xy will also be greater than 6. And 6xy, which is 2 times 3, will also be greater than 6. So the answer is 4. Okay. Now, I know how to do this mathematically. I'm going to show you that. But this is what I did in this question. There was no point of using mathematics here because it's a fairly straightforward question. There is no other way I can get a factor which is bigger than 6. Because 2 and 3, if I combine them in any way, any which way, they are going to give me exactly 6 as a factor. They can't give me anything greater than 6. So only if xy is involved in the factor, basically, then only it will be greater than 6. Now I have a question from MVG Kanan. It says, isn't x6xy the number itself? That's good. Yes, 6xy is the number itself. And please understand, and this is one of the basic concepts you need to understand, a number is a factor of itself and a number is also a multiple of itself. Okay, so please understand, the definition of factors allows you to take the number as its own factor because a number divides itself. Use the logic, right? A number divides itself, so it's a factor of itself. A number is a multiple of itself as well. Okay, these things are very important. Similarly, 1 is not a prime number, not a composite number. It's neither of the two. Okay, those are small minor things which might not remember even in the heat of the test in the test environment, but it's important to stay calm and composed and keep those in mind. Okay, so using this it's sufficient to solve this question. But let's say if the question was a bigger question, just give me 1 second, guys. Again, I'll have to sip some water. And sorry for this, guys. Yes, guys, I'm back. Sorry for the minor disruptions. Just under the weather. Yeah. So Natasha says, can I use any 2-digit number to solve? Yes, Natasha, you can do it, but all I'm saying is you don't need to. Like technically, you don't need to do this in the question. If you understand the logic, you have the logical understanding of what's happening here. You can draw the inferences. You can just do it like that. You don't have to like even multiply, and otherwise you'll go into the math unnecessarily. But anyway, the right way to do this, mathematical way to do this, would be to write the number as this. Okay. Now, if I write the number as this, I know the total number of factors total number of factors of this number is going to be 1 plus 1. There's a formula that we can use into 1 plus 1. So that will be 2 into 2 into 2. So there are total 8 factors. Okay. Now it is asking for how many factors that are greater than 6. Now this number only has 4 factors which are 6 or less than 6. So you can just subtract it. So even if the question is bigger, the question is more complicated than this, you can just simply find the total number of factors. Don't try to manually note this down. Like I've seen questions where the real answer is 12 or 15 and students literally write down numbers manually. Don't do that. I did it manually only because it was a small example, small question. Otherwise, this is the right mathematical way of doing this question. Okay. Now let's move to question number 8. Now this is the second and the last DS question that we have for today. Let's get into it. So if P is a positive integer, is P a prime number? So all you care about is whether P is prime or not prime. Again, if you get a conclusive proof of either of the two, the statement is going to be sufficient. Now, if you look at statement 1, P and P plus 1 have same number of prime factors. Now, does it tell us that any one of them is prime? Honestly, if I look at it that way, right away, no. It's always possible that there could be two back-to-back consecutive numbers which have the same number of positive factors. Like say, for example, I take 2 and 3. Okay, both of them are prime and they have exactly 2 factors. 2 factors. So in this case, definitely P is prime. But let's say, for example, I take another number. Let's say 2 times 4 and 3 times 5. These are 2 numbers, good numbers. If you look at the number of factors for this number and this number both, they exactly have the same number of factors. 4 factors here and 4 factors here. But is P prime? Definitely no. So I can't be 100% sure with statement 1 because statement 1 doesn't tell us conclusively whether P is prime or not. It could be prime, it could be not prime. Let's look at statement 2. If I look at statement 2, statement 1 is this. Statement 2 says P minus 1 is a factor of P. Now, there's another important property. If you know this, and this is again another thing which we teach in our GMAT course. Any 2 consecutive positive integers, there's a bracket, except for something, are co-prime. Co-prime basically means they don't have any common factor between them. In fact, if you look at the numbers basically, which are like the only exception to this, there's one exception to this, let me not write it like a bracket. The only exception to this is when you look at 1 and 2. Okay. In fact, that's also in a way co-prime, you can say. Co-prime is like they don't have anything else common except 1. 1 is common between all of them. So I don't have to say it's a exception technically, but you can understand that the only scenario when one number is a factor of other, basically a factor of other, like which is consecutive numbers, the only scenario when this will work is 1 and 2. If you take any other number, let's say you take 2 and 3 or 3 and 4, they will never ever be like multiples of each other. It can't just happen. Okay, and there's a reasoning behind it. There's a proof behind it. Not the right time to show you the proof, but yes, it's conceptual. You think of it, you can get to it. But the idea is any 2 consecutive integers, positive integers, are co-prime. So the only case when one number is a factor of other, despite being consecutive, is when they are 1 and 2 themselves. So that means P is equal to 2, and if P is equal to 2, it's a prime number, and we get a conclusive answer, and that's why statement. The correct answer to this question will be B. Okay, I hope that is clear to all of you guys. Let's move ahead to question number 9. Now, this is a quadratic equation question. Another interesting question. There could be multiple ways of doing this mathematically and all of that. I'm going to tell you the best way to solve this question. Now, let's look at this. A quadratic equation is of the form x squared minus 2px plus m is equal to 0. Now, I look at this. I see m is divisible by 5 and is less than 120 and is divisible by 5. One of the roots is equal to 7. Now, I know for sure that m, if I know the roots are alpha and beta, I know the product of the roots is going to be m, because that's what I know as per the quadratic equation is, right? The product of the roots is c by a. In this case, c is equal to m, a is equal to 1. So product of the roots is m. Now, if one of the roots is 7, I know m is a multiple of 7. M is a multiple of 7. M is a multiple of 5. That means m is a multiple of 35. And if it is a multiple of 35, the only three scenarios possible. M could be 35 or 70 or 105. If m is 35, then the roots are 7 and 5. If m is 70, then the roots are 7 and 10. If m is 105, then the roots are 7 and 50. Right? All these inferences I can draw till this point. Okay? And very important in algebra, even general word problems or quant or even DI questions for that matter, to draw the inferences as you read. Because if you draw the inferences as you read, you're solving the question along the way. A lot of people don't do that. They read the entire question and then come back and draw the inferences. And when they do that, they make mistakes because they forget about key pieces of information. And when they do forget about key pieces of information, they're not able to draw the right inferences, which doesn't help them connect all the dots. Okay? Sorry, guys. So important to fill the gaps, get this inferences out as soon as possible. Now, I know P is a prime number. Now, if P is a prime number, I also know from this equation that my sum of the roots is 2P. Okay. Now, see, if you look at the sum of the roots in this case, it is 12. If you look at the sum of the roots in this case, it is 17. And if you look at the sum of the roots in this case, it is 22. Now, obviously, since the sum of the root is a 2p, that means it's an even number. It can't be this scenario. So this case is not possible at all. So it is either 12 or 22. Now, if 2p is equal to 12, then p is equal to 6. But it says p is a prime number. So this case is not possible. That means m is not 35. M has to be basically 105. So I'll just write m is equal to 105 on the side. Sometimes you write it on your paper and then you just forget about like what the variable value was, and you or you sometimes like miss out on it. You like confuse yourself a little bit. So I just write it on the side. Okay, this is important. Okay, now I know this. I know p from here is 11. That also I'll write on the side. P is 11. I have another equation. So if all of this is clear, I'm just gonna erase a few things here. So this is to make space for the next equation. So the next equation says that if p is a prime number and one of the roots of the equation, there's another equation given to me and I've given the root is 12. So let's see that equation. Let's use that equation as well. So I have x square minus, I know p is 11, so I can write directly as 22x plus n is 0. One of the roots is 12. So if one of the roots is 12, I know the sum of the roots is 22. So sum of roots is 22 and one of the roots is 12, then I can find the other root, right? So the other root will be 10. Now if I know the other root is 10, n is the product of the two roots. So n would be basically 12 times 10, which is 120. So I have n equal to 120. So the question is asking me for p plus n minus n, which is easy now. 11 plus 120 minus 105. If I do this, I get 26 as my answer. Okay, guys? Very, very simple. Okay. So only Stonks is the question. When is Sn the formula valid? Isn't the correct formula this? See, both of them are the correct formula. Great, Sarthak. Sarthak has just shown the proof of the formula. Understand, the first, like just going back a little bit, guys. The first, sorry. Just 1 minute, guys. I'm sorry for this. Yeah, I'm back, guys. So for the series sum, the base formula is sum is equal to n into average. From there, the second formula is derived, which is sum is equal to n by 2 into first term plus last term. And as Sarthak said, the third formula, which is what many of us use as our base formula, n by 2 into 2a plus n minus 1 into d, is derived from the second formula. So it's like a living series of formulas which are derived from each other. But the base formula, which is sum is equal to n into average, is the best formula to use in case of arithmetic progression, see sum calculations. Okay, let's move to question number 10, which is the last question and by far the most difficult. Now the question is difficult because of the language, the way it is written. To decipher it, it takes time. And guys, when I saw this question for the first time, which was like shared with me today itself, so I looked at this and I was also like, it was little difficult to understand in the first place. But what happens with me is that, and I teach it to my students also, as you see a question which is difficult to understand, you need to go through it slowly. You need to decipher it slowly. You need to reduce your pace of reading. So never follow, no, never have the same pace of reading for every question. A lot of people read the questions really fast and then come back to it later. That's a very bad strategy. You will end up being confused. If you want to give you 100%, just make sure that you are reading the question slowly. And please understand, guys, I'm not here to just solve these questions. I could have done that in like 20 minutes and be done with the session. I'm just trying to teach you very important learnings which I've seen with my students who have had great achievements, have improved their score by 100 points in like 30 days or so, and some people improved by even 70 points in just 12 days of time. I've seen these people kind of implement these strategies and how much these strategies can actually like change about them. So important for you to understand these things. Never have the same pace of reading for every question. Slow down in the first read itself if you see something is tricky. For example, let's see this. A decade, again, when I see a decade, I see, okay, decade means generally 10 years, but I should not bring that outside knowledge because it's trying to define the decade. A decade is defined as a complete set of consecutive, important set of consecutive. It's a set, it's multiple numbers. Non-negative integers. Non-negative means, what is non-negative? It includes zero, right? 0, 1, 2, 3, like all these numbers. It's a consecutive set, a complete set of consecutive non-negative integers that have identical digits in identical places, okay, except for their units digit. All right, so it's a set of numbers which have identical digits in the identical places except for their units place. So every other place is same, as in the tens place, the hundreds place, they could be same. That's what a decade basically means. So ideally, if I look at the numbers, like for example, if I look at these numbers, these set of numbers, all the way to 09, this and this would be a decade, technically. Because if you see all these numbers, the only thing which is basically changing is the units digit. Every other number is same, right? You see 0 here, 0 here, 0 here, 0 here. It's a complete set in itself. The moment it changes to 1, that's a different decade. So this is decade 1, this is decade 2, and this is decade 3. Understood, guys? 0 is not positive, Harsh. Yeah, just like 1 is not prime. Okay, important lesson, very important trick that GMAT is. In fact, I've seen some really straightforward questions where they play with this trick. They say non-negative, people consider 0. Okay, sorry, non-negative includes 0, but they people consider 1 directly sometimes. Okay, so 0 is non-negative. Always remember, non-negative, non-positive. Okay, now let's see. So let's read the question again. With the first decade consisting, we have already talked about that. First decade consisting of the smallest integers that meet the first criteria. Second decade consisting of the next smallest decade. So I have already written that down here. A decade in which the prime numbers contain the same set of units digit as do, okay, we are comparing with which, as do the prime numbers in the second decade. Okay, so we are talking about the second decade. So let me isolate this. So we have to look at this decade. Okay, so let me just get rid of the other decades for now. Just to focus better on this one, I'm just getting rid of the other decades. Okay, so this is my decade 2. The question is saying which of the decades have basically contain the same set of units digit as do the prime numbers. Okay, sorry, a decade in which the prime numbers contain the same set of unit digit as do the prime numbers in the second decade. So let me start with the prime numbers in the second decade. 11, 13, then I have 17 somewhere and 19. These are the prime numbers in the second decade. So I have to look at the other decades where the like prime numbers contain the same units digit. Okay, so let's see. Now, obviously, you can go to write 3, decade 4. You can try that out, but that's not required because we have to just look at the options, right? We have to look at which one of the options work. So let's look at decade 5. Okay, now what will be decade 5? Decade 2 starts with 1, decade 5 will start with 4. So it will be 4 0 4 1. Now 4 1 is prime, right? 4 2 4 3. 4 3 is also prime. Till this point it's all good. Let's go to 47. 47 is also prime. Now 49. 49 is not prime, right? So this decade will not work because it doesn't have the same set of units digit, right, as the prime number in the second decade. In the second decade, the units digit set is 1, 3, 7, and 9. In this one, we have 1, 3, and 7 only. So they are not the same. So definitely not the answer. This way, we will check the seventh decade. 60, 61. Again, we just have to focus on these four numbers, right? 61, 63, and so on. 63 is non-prime, out. Okay, I need to have all this 1, 3, 7, and 9. The numbers ending with 1, 3, 7, and 9 as primes. Eighth decade, 71, 73, 77, and 79 is what we care about, but 79 is not prime. 79 is a multiple of 7, out. Ninth decade, 81 itself is not prime, right? 81 is a multiple of 9, out. By elimination itself, the answer is 11th decade. Now, those of you who want to put in the extra effort can check out whether that works or not. But since by elimination, this is the only one left, has to be the answer. Now, just for sake of satisfaction to all the people who are doing this question, let's just check the 11th, but I don't recommend checking it in the test if you do the other decade slowly. What is very important here is that don't rush while doing D5, D7, D8, D9, because if you rush and make a mistake in the calculations, which a lot of people do to save time, they think I have to do so many calculations, let me rush through them and save time. What they don't realize is, if God forbid you make a single error in the calculations, you get the wrong answer, you'll either get the question wrong, or if you don't find the answer matching in the options, if you try to redo the calculation, imagine the amount of effort you need to put it again. So I always recommend, if the calculations are tricky, either find a better way to do it or go slow with the calculations. Don't commit an error in the first place. So in the test, I don't recommend rechecking at all. In fact, I shared the same learning with Ria, one of my students, and she implemented this learning. And one of the key learnings which helped her improve her score from 615 all the way to 715 in just a matter of 15 days. Okay, guys, unbelievable, but true. 15 days, she was able to jump, make such a huge change to her score, right? If you want to check out her story, you can check it out in this link. It's there on GMAT Club YouTube channel itself. But yes, so very important that you don't recheck at that stage. But just for learning purpose, I'm going to do that very quickly over here, since again, it's not a test right now. So let's do D11. D11 would be 101, 103, 107, and 109. All of these are prime numbers. So this set works. This set is the next decade after the second decade, which will have the same set of units digit for all the prime numbers in it. These are the only 4 prime numbers in that decade. Okay, guys? And that is what your answer is. Now, the reason why this question, I like this question is because I'm not saying the exact same question can come on a GMAT or they will make it this complicated or not. But GMAT generally tries to create stories around simple scenarios, and you need to kind of look beyond the story, simplify it, not get intimidated by these questions. Tough questions to read and understand, but you need to give yourself a little more time to do that. Okay, and this is the 805 level questions for that, 805 level question for that reason. Okay, guys. So that's about it. I hope you guys learned a lot from us today, like me today, about what are the different strategies you can apply. I tried my best to give you lessons around the questions, not just limited to the solutions of those and what you can possibly use in the other cases as well. In case you want to reach out to us, feel free to do that. Like, details are on the screen, and I'm happy to take up any questions that you might have, guys. Okay, I'm gonna be happy to take it up. If you have any questions, feel free to just throw up to me, or you can just block a time on my calendar if you want to understand how we can help you get to the score. And who knows, you could be an inspiration to other people like you. Yeah. Thank you so much, Natasha. I'm happy like you found the session helpful, and Raim Kram as well. Thank you so much. So guys, do attend the sessions. I think I am doing another one. I'll just check my calendar. I guess there's another one that I'm doing in about 3 weeks from now. It's on 6th of July, if I'm not wrong. But yes, do attend this, and we do this like to help you understand how to use the better methods. So thank you so much, guys. I don't see a question right now, so feel free to reach out to me. I have the details on the screen and my link to book a call on my calendar as well on the chat. Feel free to reach out in case you need any help. We are more than happy to help. Thank you, guys. Have a good evening. Bye bye.